Welcome to TFR. Let's talk. I'm your host, Swapnil Bharti, and today we have two guests from Varada, co-founder and CTO, David Krakov, and Vice President of Products, Ori Reshef. Ori, David, it's great to have you on the show.
Nice to be here. Thank you for having us.
Yeah, and today we are going to talk about creating analytics ready data lakes. This is a topic which is close to my heart because I cover it very closely. So before we get started, I want you folks to explain a bit what is the difference between data warehouse and data lake.
Okay, so let's start. Let's start with the basics. Let's say that a data warehouse is a solution for storing and compute on your data, where storage is a scarce resource. You need to plan for it. You need to build your model wisely and correctly, because storage will cost a lot. And then compute will talk later, but you need to be very mindful of your storage. It's very limited, and your schema needs to be thought thorough. While data lake, you don't have these constraints. Storage is almost close to endless, but very low cost. And most important, you can keep your raw data. And we'll talk a lot about the benefit of not modeling or aggregating or losing granularity of the data. That's the big thing for data lakes. We can put data at its raw form with a reasonable cost.
Furthermore, because of the flexibility of the data lake, there's just so many data types that go there. Dynamic data types like clickstream data and product analytics and IoT data and semi-structured social data. There's so many different, diverse, new kinds of data which are too fast, too changing for data warehouse. And first thing to solve the scale of how to deal with that data, and the data lake becomes the first step to getting there.
Also, just to get an order of magnitude, if we're talking in data warehouse of storing tables that are tens of millions of rows, hundreds of millions of rows, now we're talking about hundreds of billions of rows. And that's a major, major difference.
Yeah, thanks for explaining that. Now, if you do look at data, raw data itself has no value. You have to extract value out of data. In today's world, when people, we are collecting a lot of data, we are creating a lot of data, and sometimes you have to move your data out of your warehouse to the analytic. So not only, you're talking of petabytes, depending on how much data you have, unnecessary complexity. So can you also talk about this whole movement of data, which data warehouse, it makes it even more challenging. So let's look at it from that aspect as well. Which one makes life easier when we compare the two?
Well, actually, probably the most common query for a data lake today is loading data into a data warehouse. And this is because of the limitations of querying with the data lake. And these limitations are not only about having just raw data, because usually data, once it's queryable, it's mapped somewhere. But it's about data engineering, getting the data ready. It's about performance, enabling the exploratory, iterative flow of data analysts. It's about cost efficiency, because at the end of the day, every analytics team has a CFO somewhere that counts the resource spent. And fighting all of that is just running queries in the lake. It becomes very hard. Should we talk about data scans? Okay, I'll do that. One of the things happened, to get to the root of why this happens, because the lake is so good in storing the data without thinking how to use that after, that creates a true burden on how to query that.
And that's a part of your comment actually earlier on. You said, okay, but data is dirty and we need to clean it and we need to organize and aggregate. Well, not always. And you can decide on which part of the pipeline you want to do this in order to gain granularity. True, you're absolutely right. Data is dirty and doubles, and all of us here who deals with data know the pains on data cleansing. That said, it depends where in the pipeline you do your cleaning. And as David said, there is a point where you can actually grab the data, keep it at the rawest form you can, clean it in the compute on its way to a consumption and not beforehand. And that's also kind of a change that we see moving to data lake. Why? Because you can gain a competitive advantage from like 10 columns you didn't even know exists. And these are the dimensions that will bring you a new product or a new insight for your customers. So that's a delicate game because it is complex, right? I want to clean data, I want SLA, right? I want response time. And as David said, so what we see today is kind of a movement to put everything in the data lake and then ETL it out into a data warehouse, which is kind of also problematic, right?
Like you said, raw data. And when people say raw data, sometimes it actually means just granular data. Yeah. Not throwing data away. Because when you aggregate that data for consumption, say on a hourly or daily or whatnot, you basically throw a lot of the signal, a lot of the visitor level information, a lot of the click level, all the dimensions that got aggregated away. But now that you try to understand your data from a new viewpoint, you can't because you threw that away. So when people talk about raw data, it's not the data I can't even query. It's the data that holds all the signal that can be used for my insights.
We actually see it also in data science groups. They are the first and biggest, I think, and most efficient consumers of this granular, let's call it granular. It's a more appropriate nomination of real granular data because this is the alchemy. This is where you can create new things from data that you did not know. We're talking a lot about the gray data and data that we only know a very small portion of the data. Data lake is very exciting from that perspective, from what we can see.
Which are the kind of use cases that you see which are kind of shifting from the traditional data warehouses to data lakes? And one more thing I want to talk about is that when it comes to these modern technologies, like, we are seeing so much innovation happening in the cloud native space. When you look at data lakes versus data warehouse, where you do get stuck, in whatever structure they have, versus you can move with the latest innovations that are happening in AI, ML, and in the cloud native world.
Yeah, I'll take the second part and you'll take the first. It's funny that the whole data landscape became so complex for people to understand because of the claims of everyone doing that fast and better and more efficient. But my view here is I think about that as a stack that supports the different needs. At the bottom of the stack, you've got how do I store all my data? And the fact that everybody moved today to decouple how do I store and how do I analyze that is a positive thing. It helps deal with changes in scale. You've got then a level of stack of how do I map that data, catalogs and so forth, and governance, and how do I access the data. I have, on top of that, the actual languages, the query engines, and this is the stack today. And when we come from where we come from, we see that this stack lacks a pot. Because it's not just to query and to store. You have to do that in a way that is efficient and decoupled from everything else. What do you query and what do you store? This is essentially what we do. But whatever technology there is there, I always try to map that. Does it fit this way of independent scale-out layers that can serve data infrastructure that can grow and serve multiple use cases, or does it not? When it does, then every company can fit in that step. When it does not, then you get some of the problems of the classic data warehouse, which is entanglement, which is the inability to scale in some vector.
Well, what we see is actually two different use cases, two categories of use cases. One is the internal analytics, and the second one is the external analytics. And you take what David said, the stack that is being built, and you take another factor, which we reminded, which is the CFO factor, which is the cost performance factor. And then you look at your two big needs, the external and the internal analytics. and they can be in very, very different ROI situations, right? External analytics is client-facing. If this does not work well, if the SLA is too slow, if you're getting wrong answers, you get churn. And that's bad, right? That's the worst thing that we can do in supplying analytical software. You want to be fast and you want to be accurate. And then the stack needs to answer that. And if you're doing internal analytics, then you can also find two different use cases. Internal analytics that will keep the enterprise going, will bring it money, innovation, and will help the day-to-day. You know, the analysts, all the BI tools riding on top and telling production, this is what happened last night, this is the changes, etc., etc. This is internal analytics of one type. Data science is internal analytics of another side, and then there are other cases, and they are very different also in their nature, because most of the external analytics will be like the use case that David described. There is a fixed query that is hitting an ultra-optimized data warehouse and giving the responses. But what happens when your customers ask you for, well, can you add this dimension? And I want this calculation also. You know what? I need to drill down and understand why this thing is happening. And this breaks. Now, if you're working with the stack and working the stack that David mentioned, and it's flexible, now you can model it and tune it to those two cases. There are cases where data warehouse is fine because you have your stream of very templated strict queries. You just need to answer fast, and that's a data warehouse. And you don't have a lot of data, and your customers are happy with that. Stay with that. If you need to innovate, if you need, you mentioned that earlier on, if you need to scale, if you need basically much more flexibility, you will go and build the right stack. Not the data lake is one part of it. You called it, I think, the bottom part, the storage. But you need to understand that in order to use it, you need a couple of layers on top of it to make it actually operational to fit those two categories of analytics.
Analytic ready.
Analytics ready, yes.
To get to the first question you asked, which I still remember, which is the use cases. Give you an example of a use case. What constitutes a use case where the journey you're going to take on the data is dynamic? Well, so give you one example. For example, incident analysis in cybersecurity. When you get, and you can translate this to root cause analysis, to journey analytics, to behavior analytics, a lot of different workloads operate like that. You have on your lake hundreds of different types of events. In the case of cybersecurity, it might be connections and running applications and audit logs, which is some kind of a sparse matrix of things that are happening and can be connected versus by different IDs, the same IPs appearing there, the same time. And when you're trying to understand a breach, the way you're going to track that may be very, very different and unexpected. You might build, we call it dependency tree. This led to that, that led to that. You might look at different hypotheses to compare what's happening here with that anomaly. And you do that across those hundreds of event types because you don't know where you're going to get, you don't know where the breach is. So this is essentially a workload that is multidimensional, extremely dynamic, on data that cannot be modeled for, and is actually very short-term oriented. You have to find and understand and close and find the fix, so you don't have time to waste. And there are so many parallels to that, whether in marketing world or in manufacturing world and different verticals. But this is essentially the basic problem. When you don't know how to get and where your data is and how to understand that, and the work there is exploratory.
If you just focus on data lake, how analytics ready is architecture of data lake? If it is not fully analytics data ready, what are the things that are still missing there?
I think we started with the fact that the data lake solved the storage very well in a low cost, and you can go as wide as you want. Compute is not solved. Compute is costly, and compute is separated from the data, which is a good thing. But you need to think very hard on the in the data lake domain on the cost performance. How much do I want to spend on the compute in order to explore my data? And then the entire equation is very interesting, because you can optimize from the bottom, from the ETL going into your data lake, so you will reduce your compute, or you want to build ultra optimized queries, really as optimized as possible to reduce compute. Indexing is an interesting solution for that, and that's how you need to think on building the architecture. How do you make the best? I'll call it compromise, but it's not compromise. The best ensemble of compute and storage for your needs.
And the decoupling of compute and data, which you get on data lakes, you get the query engine running on the data. When you start to take into account cost performance, becomes a bit of an illusion, because your query going to scan 200 terabytes of data, that's going to be slow and expensive. So you need a data engineering firm to create materialization, which fits that query pattern and make sure that runs and up to date and refreshed, and everything that's dependent on it is updated as well. Suddenly you couple your queries with how you store your data and how you manage that, and this architectural decoupling becomes an illusion, which just happens on the non-analytic data-ready data lake. Because as you start to build data products with that, or start to build interactive dashboards with that, you end up solving the cost performance problems with entangling, with data engineering, with more and more different ETL flows, or with loading back to the data warehouse where we started from, and losing all the benefits of sitting in a data lake.
Which is quite amusing, right? Because you went to the data lake to benefit from the data lake, and you're ETLing back to your data warehouse and sticking to your old solution. You just added another stop.
Yeah, and so the gap there is, how do you enable this without that data engineering, without that entanglement, without the fact that when you do build a data product of that with SLA, you want to be able to query the data, and you want to be able to deal with high dimensional, different data sets, changing schemas, all the benefits of why you store stuff in the data lake in the first place.
Right. Since we are talking about all the benefits and strengths of data lake, I also want to talk a bit about, what role does, indexing technologies they play, how can they kind of transform data lake into a kind of analytics ready technology stack? Because we are talking about the up and down of the stack.
You can start by your example with the 200 rows you just gave, right?
Well, a lot of that comes back to cost performance. And indexing, classic databases, like you had your old MySQL Postgres, you added an index and queries ran faster. You can do that architecture on data lake today. But then when you understand a lot of the workload is actually rather selective, you understand the journey of a specific customer cohort, or because the signal lies in the granularity, in the details, indexing suddenly becomes a great solution. And furthermore, we do a lot of workload analysis, and we've seen that from companies who do that internally, and they've seen that 90% of the resources of the time of query engines on data lake is just spent on data scans, which is amazing, and
we also have we see that we have an interesting tool that allows companies to examine the usage of their CPU. On what type of operators in your query are you spending your money? And as David mentioned, 90% on scanning.
And people are amazed by that. No one expects that. Though when you think about it, it's easy to explain. The data was not modeled for a query, so you end up scanning lots of it. And so indexing becomes a solution. But then it's not just about indexing, it's about indexing cost effectively. Because if you just index everything in the lake, that becomes cost prohibitive, and be performant and serve everything. So it's about indexing, but indexing in a way that's smart enough to know what and when, to prioritize the resources that spent on indexing. This is what makes indexing from a theoretical solution to a problem to one that actually works, being able to do that cost effectively.
So if you do look at, we're in the middle of this year, a lot of innovation is happening. Last year, a lot of companies, they rushed to digital transformation, to cloud native because of this pandemic, because cloud was the savior. Now they are settling down. It's like the hangover is over. Now they are hitting the actual problems that they see. From data's perspective, what kind of patterns you see, that how it is being embraced, adopted, and what are the hurdles that companies are facing? Of course, data warehouse, it has its own set of complexities. Data lakes, I mean, the cost is a big factor. Being able to provision quickly is also one factor. But what do you see is kind of helping customers to quickly move, and at the same time, what pattern do you see that you are learning from them as well?
Well, you can return back to the office as the offices open up, but you can't undo digital transformation. This is a one-way street. And by the way, the decoupling nature of the data lake, you could just throw data in and run in Athena or a similar query engine of that, is extremely agile. And so that helped speed up the digital transformation that everybody went through at super accelerated pace along the last year. Though they end up with a mess, and this is the time to make it efficient, because at first it was about being able to work and being able to serve the customer side as they move to digital channels. But now it's the time to make it, that's going to stay. So that's the time to make it efficient, to make it serve, to make it, to get the value from that accelerated digital transformation. And you are correct. We've seen so many companies who were talking like a couple of years ago, and they were, we're going to think we have this data lake project. I'm talking to them today, and everything's operational, and now they're solving problems and pains that are acute now.
It did accelerate, but one thing is very interesting, and I think we see it in a lot of places. The understanding that you need a data lake came very quickly. You have multiple data warehouses, multiple data sources, separate doubles. So there is this understanding that you want a single source of the truth. You want a place where everybody asks a question and get the same answer, which is nice, right? And the problem of scale. But then came another problem where the business layer and the decision-making layer of the organization did not understand, but the working technological layer did understand it very quickly, and that's competence and skills in this new domain. Because when you build a data warehouse, it's not enough to put your data in one of the public clouds, data lakes, or your own Hadoop installation somehow. You need people who actually understand. You need people who understand what is ETL. You need people who understand scale. Because, again, the difference between 10 million rows and 100 billion rows is significant. One of the definitions of big data is the size is a part of the problem. It's not only the algorithm. You need to take into account the size and the scanning and the time and the cost and the technology and the stability. And then we see this movement in the market to look for experts in this domain who understand streaming, who understand the how do you deal with that? How do you deal with ETL? And it's growing very fast. I think this 2020 year that was a challenge was an amazing acceleration for that. People needed to get those skills, period. We need good data engineers. We need excellent DevOps. These are domains that grew in knowledge and in importance when these data lakes came. And then the organization went, okay, let's do this digital transformation. Let's do this data lake thing. But nobody actually knows. Nobody knows actually how to do it. It can work on a POC scale where a good intelligent engineer is starting to say, okay, this is working. But now you go to production and things start to happen, right? We see that a lot.
Since you actually touched upon something which is also close to my heart, which is like the people side of the story, not just the technology side of the story. Do you see any gap in supply and demand of data scientists or people who do understand it very well, or you still see there's a huge gap?
We see this gap closing, and interesting to know what you think, David. But we see this. We see that there is it's a scarce resource again. People who actually know big data, who actually know the stack of technology you need to be very fluent in. What we had, the kings of databases, the DBAs, need to understand different languages and different contexts now. IT, that was essential, is transforming into cloud, into DevOps. And DevOps are writing extremely complex codes today to make your environment stable. I think that we need to accelerate in closing the gaps, and more people taking more courses and getting more familiar. I think it's something natural that will come because this it's happening. We see, but there is still a lack of knowledgeable resources in this domain. What we can see is DevOps for sure, and data engineering in general.
Yeah, and by the way, I think that data analysts are really underserved in terms of, because you still start dealing with infrastructure problems when the solutions are there, but then they're the end user, and when things are slow, things are failing, things are requiring to wait for someone to answer someone. This is a lot of frustration and inefficiency. The whole productivity was lowered during the last year, but they're just an underserved sector here. And everything that can help the analysts to work in a way that makes them independent from data engineering, from everybody else, and make it fast enough for them to be able to sustain and exploit their flow. I think that this is very important. And there are so many, when saying data analysts, there are just so many people who do that and not necessarily have this title. This is the whole buzzword of the democratization of data, which you can still think about it as a buzzword, but at its root is being able to give people at an organization the ability to run queries and get answers themselves.
That's the understanding that internal analytics can turn your organization around. If I have access, because each individual, you said about people, this is completely people. You have talented people, you invested money into them. Give them access to all your treasures. They will do wonders. And these are the frontliners, are those data analysts. They're bright people that love data, love to investigate, like to find new stuff. But let's go back to the data warehouse. Give them a strict schema with low to no granularity and a lot of aggregations. You just get a smart report. Give them the flexibility to query your granular data, they will do magic. Give them the access. Say, everything is open. You just go and log into this UI and go, and the data lake is open and just query. Organizations that do that, and we know some, the big ones actually do that and do that very, very well. They separated the dependency between the analysts and DevOps and data engineering. They prepare it as a good data platform that everybody can freely access, and I don't need to call anyone or call in for favors to get enough CPU and storage so I can do my research. I just click on a button and it's there, and I can do my work. So yeah, that's what.
Yeah, but most of people don't work in
those companies.
Yeah, in those hyperscalers, which can build data stacks for themselves.
That's one of the reasons that they have this advantage in the market, because they can run so fast, because data is free to anyone, because every decision can be backed by numbers. It doesn't matter who am I in the organization. If I'm a junior that just started, or I'm the CEO, I have the access to the same data. I can make a claim and I can prove it. And then the organization said, if you have the numbers, if you proved it with numbers and with data, it's not an opinion, it's a fact. So let's advance. And these guys are moving very, very fast.
Yeah. When I was listening to you, there are so many things that you folks pointed out. As we talked about, that last year companies were like rushing towards cloud. We talked about the scarcity of talented engineers. If you look at all of these things, capabilities, limitations, what are the use cases that can be immediately directly served through data lakes? So there is a very clear path. Hey, you know what? If this is what you're going to do, data lake is the way to go.
Data science first, I think.
Data science, exploratory analytics. And again, I'm usually thinking about it not from what. Try to start from a business problem. What kinds of data, what kinds of questions are best served by a data lake? For example, the instant analysis,
and wherever you need dimensionality, high dimensionality, and high granularity.
Yeah, and this is where we can excel with that. So it's not that I started a tech, I have a data lake, let's see how do you make it useful. And there are, the word of time where people just did a data lake project because that was a cool thing to do, and those projects usually fail.
Okay.
It's about knowing that these kinds of business problems, which deal with diverse, changing, dynamic, large data, high-dimensional data, this is where you're gonna, if you want to solve them in a fast, if you want to solve them efficiently, if you want to build data products with that, this is the right stack to deal with that problem. And this is where the data lake fits.
No, we see it in, so we see this problem of scale, dimensionality, and granularity that is needed in the pharmaceutical industry. We see it in cybersecurity, which needs to do a lot of anomaly detections and at a granular level. We see it in content. We see it in IoT, right? And these are kind of cases that lend themselves immediately into a data lake. And then there are the cases where it's just logical in the sense of organization, because with the evolution of the enterprise, you created a lot of data sources, which eventually you want to federate into a same location and then advance from that.
And one thing more, I think there's because cloud data lakes are, I think they're essentially magic. S3 is essentially magic for a very practical purpose. When you start a new business today in the cloud, or you start a new product in the cloud, things like S3 or Google Cloud Storage are just one of the basic starting components that you start with. And the data warehouse isn't.
Yeah.
And so as we move there, I think this is where data going to end up. And if you start something new and you build something in the recent years, this is your baseline, and eventually you would want to keep things simple.
David, Ori, thank you so much for taking out today. This was one of the most interesting discussions that I have around data warehouse and data lake. So thank you for not only sharing those insights, but also giving a lot of tips, also how to do it right, and also about the pitfalls that companies face. And it was really interesting, and I would love to have you folks back on the show to continue this discussion. So once again, thank you, David. Thank you, Ori.
Thank you very much. And again, thank you very much for having us.
Thank you very much.